Hi class, this is lesson 6.5. Prove triangles are similar by side, 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 and side, angle, side. So our goal here is just to be able to use the side, 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 and side, angle, side similarity theorems. We did have side, 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 and side, angle, side congruence theorems. We also have similarity theorems. So I realize they do have the same names. So the first one here, Theorem 6.2 says side, side, side similarity theorem. So if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So this time, since we're doing similarity, our sides have to be proportional, not congruent. For side, side, side congruence, your sides are the same. Side, side, side similarity, your sides are proportional. So the way we do these is we're going to do the shortest proportion, the longest side's proportion, and then the remaining side proportion. So it says, is either triangle DEF or triangle GHJ similar to triangle ABC? So we need to do this by comparing triangle ABC and triangle DEF. We do that by finding ratios of corresponding side lengths. So our shortest sides of triangle ABC, so for triangle ABC, my shortest side is 8. My longest side of triangle ABC is 12, and my other side is 9. And I'm going to make proportions for all of these. Okay, so I'm going to do triangle ABC to triangle DEF. So for triangle DEF, my shortest side is 4. My longest side is 8, and my remaining side is 6. And if we reduce this and get the same thing for all three, then it is proportional. Well, 8 divided by 4 is just 2. 12 over 8, 4 goes into both, so 12 divided by 4 is 3. 8 divided by 4 is 2. And already I can see 2 over here and 3/2 here, they're not the same. So these two triangles are not congruent. Let's just simplify this last one. 9 and 6 both have 3 as a factor. 9 divided by 3 is 3. 6 divided by 3 is 2. So these two sides are the same, but all three aren't the same ratio, so it's not proportional. Now let's do triangle ABC to triangle GHJ. So again, the shortest side of triangle ABC is 8. The longest side is 12, and my remaining side is 9. I'm going to make proportions for all three of these. Okay. So my shortest side now of triangle GHJ, triangle GHJ, my shortest side is 18. My longest side is 24, and my other side is 18. So 8 over 18, well, 8 over 18, wait a second, I wrote that wrong. My shortest side isn't 18, it's 16. 8 divided by 16, 8 goes into both, so 8 divided by 8 is 1, 16 divided by 8 is 2. 12 over 24, 12 goes into both. 12 divided by 12 is 1, 24 divided by 12 is 2. 9 over 18, 9 goes into both, so 9 divided by 9 is 1, 18 divided by 9 is 2. And you see we get 1/2 as our ratio for all of them. So do you remember we used the scale factor, the term scale factor in the previous, actually 2 lessons ago we used scale factor. So they are the same, they have the same ratio, so our two triangles are similar. So we can say, oh, thought it was on there, I guess not. We can say triangle GHJ is similar to triangle ABC. So let's look here. Is either triangle DEF or triangle GHJ similar to triangle ABC? So why don't you pause the video and try this one on your own. Remember, you're going to compare triangle DEF to triangle ABC. And you want to do the shortest sides. I'm going to put S for shortest, the longest sides, and then your remaining sides. And you want to find that proportion. Then you also want to compare triangle GHJ to triangle ABC. You could flip these and do it the opposite way. You want to compare your shortest sides, and you want to compare your longest sides, and then you want to compare your remaining sides. So pause the video and try this one. All right, welcome back. You should have found for triangle DEF to triangle ABC, triangle DEF, that's 6, 12, and 9. Triangle ABC is 8, 16, and 12. And if I reduce that, I get 3/4. If I reduce this one, 4 goes into both, so that's 3/4. If I reduce this one, 3 goes into both, so that's also 3/4. So these are the same. So I know that triangle DEF is similar to triangle ABC. I'll quickly do this last one. So triangle GHJ, my shortest is 8, my longest is 16, and my remaining is 10. Okay, let's compare it to the shortest, longest, and remaining of triangle ABC. Triangle ABC, that's 8. My longest is 16, and my remaining is 12. Real quick, I can see that's 1, that's 1. This is not equal to 1. So because they're different, these two triangles are not similar. So we can say, make our similarity statement, triangle DEF is similar to triangle ABC, and we know that by the side similarity theorem. Example 3, find the value of x that makes triangle ABC similar to triangle DEF. So if they're similar, then the sides are proportional. So we can set up proportions here. So I'm going to set up a proportion for the sides that I know. Well, here's one of my unknowns. It says find the value of x. So here's an unknown. And this is a corresponding side right here. That's 18. And actually, 4 and 12, those are corresponding as well. So I'm not even going to worry about that bottom part because I can write a proportion this way. I can say 4 over 12 equals x minus 1 over 18. There are other proportions that you could set up. I just set this one up to solve this. So let's use the cross products property. Got 12 times x minus 1 equals 4 times 18. So distributing here, I have 12x minus 12 equals 4 times 18, and 4 times 18 is 84. If I add 12 to both sides, I have 12x equals, oh, that's not 84. Did that wrong. Let me check here. 4 times 18 is 72. I added my 12 a little too soon. So that's 72, and if I add 12 to that, then I get 84. Dividing both sides by 12, you'll find that x equals 7. So x equals 7, and if we check this, 7 minus 1 is 6. So if I just do a quick proportion, 4 over 12 should equal 6 over 18. Just to check it, I'm doing my sides here. 4 goes into both of these, so this becomes 1 over 3 equals 6 goes into both of these two. So 6 divided by 6 is 1, 18 divided by 6 is 3. So those are proportional. It does check out. Our next thing, side angle side similarity theorem. Again, we had a side angle side congruence theorem. That was when your sides were congruent and the included angle was congruent. Now we're going to say if the angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So remember, with the side angle side congruence theorem, your two sides had to be congruent or equal. Now with the side angle side similarity theorem, your two sides have to be proportional. So let's look at this. Use the side angle side similarity theorem. So example 4. Is triangle FDM similar to triangle ABQ? Excuse me, I sneezed. So I'm going to redraw this so that my pictures are oriented the same way. I'm going to redraw this small one down here. So here's my right angle, and that's V. Okay, I've got my shorter side here, so I'm going to put my shorter side here. It needs to be 3, so that A goes here and the Q goes here, and this is 4. So they both share that right angle. Let's check to see that these sides are proportional. So I've got 3 over 6, and does that equal 4 over 8? 3 over 6 is 1/2, and 4 over 8, yeah, that's also 1/2. So my sides are proportional. So is triangle FDM similar to triangle ABQ? Yes. By the side angle side similarity theorem. Let's look at example 5. It says, is triangle GHK similar to triangle NMK? So again, I want to redraw this smaller triangle so it's facing the same way here. Okay, so 4 is my smaller side, so I'm going to put that on top. I'm sorry, 4 is my bigger side, so I'm going to put it on top. And 3.5 is my smaller side, so I'm going to put that on the bottom. And if you notice, they've got vertical angles here. So this angle, these two angles are congruent. That's by vertical angles. So let's check here. 8 over 4, my congruent sides. And I also have 7 over 3.5. Well, 8 divided by 4 is 2. 7 divided by 3.5. That's also true. So are my two triangles congruent to each other? Yeah. I'm sorry, not congruent. Are they similar to each other? Yes, they're similar. And that's by the side angle side similarity theorem. Notice how for both of these I redrew it. For this one, I also want you to notice if you had put 4 over 8 and 3.5 over 7, you would have gotten 1/2 and 1/2. And that's okay. They're still the same, so it's okay. If you flipped them upside down, it's not a big deal. So our triangle similarity postulate and theorems. These are the ways that we know that we can say triangles are similar. We've got the angle-angle similarity postulate. We've got the side-side-side similarity theorem. And we've got the side angle side similarity theorem. So you need to be able to recognize when each one of these is used. Okay, so choose a method. So we're going to choose a method. Example 6, tell what method you would use to show that the triangles are similar. Okay, so one thing, it might help to redraw it. So I've got my new pictures redrawn right here. And in order to do this, so let's compare some stuff. Well, first of all, we've got some vertical angles here. So these at angle R are the same because they're vertical angles. So let's compare our sides. 18 over 24. And then we have 9 over 12. Let's see if they're the same. 3 goes into both of these, so that's 3 over 4. The top, 6 goes into both. 18 divided by 6 is 3. 24 divided by 6 is 4. So those two are proportional. Our sides are proportional. We've got an included angle that's congruent. So are these two similar? Yes. And our reasoning is the side angle side similarity theorem. Let's look at this last one. Choose a method. Explain how you can show that the triangles are similar to each other. So again, let's redraw this smaller one. So to redraw it, I'm going to put it right here. So this bottom side is 16, or the side of it. This longer is 32, and we know this bottom is 28 because they share this side right here. Okay? So it looks like we've got sides that might be proportional. Let's compare here. I'm going to do my shortest, my longest, and my remaining. So my shortest of my smaller triangle is 16, my longest is 32, and my remaining is 28. My shortest of my other triangle is 28, my longest is 56, and my remaining is 49. So if I reduce this, let's see here, 4 goes into both, 16 divided by 4 is 4, 28 divided by 4 is 7. Let's see here, also, this reduces to 4 over 7. And this last one also reduces to 4 over 7. So these two triangles are congruent, and they're congruent by the side, side, side similarity theorem. And this is the end of today's lesson. Make sure you starred any that you had questions on so that we can go back and work on them tomorrow in class. Have a great day.